gas laws. So today's topic is about gas laws, and of course this topic is in kinetic molecular model. Okay, so the topic is kinetic molecular model, and further is gas law. What is a gas law? A gas law is set of equations relating pressure, volume, and temperature of gas. So that's how we simply define gas laws. Okay, then as we know, there are two type of gases. One is real gases. What are the real gases? The gases which we found in everyday life is example of real gases. So we can say from everyday life. And then in atmosphere, our atmosphere consists of real gases. Okay, what's the feature of real gases? In real gases, their kinetic energy of molecules is due to their movement. Okay, and they have negligible potential energies of molecules. Like we can say that in real gases they do have some potential energy, and this is because of very weak bonding between gas molecules. So the real gas is one in which kinetic energy is of course there because gas molecules are always moving, and potential energy is negligible because the bonding between gas molecules is very weak. Okay, then there is another gas which is ideal gas. Okay, for ideal gas, ideal gas is not from everyday life, and the main feature is kinetic energy, okay, that is present, but molecular potential energy is zero. Molecular potential energy is zero. It means no bonding at all. No bonding at all. So it means the ideal gas is one in which molecules are not bonded to each other. Even with the weak forces, they are not bonded. So that's why we say that these are the ideal gases. So the only difference between real gas and ideal gas is the bonding. In real gas, molecules are having some bonding between them, although that bonding is very weak. But in ideal gases, bonding is not there at all. Okay, now let's study the gas laws. First of all, we have to study Boyle's law. Boyle's law. Okay, Boyle's law is basically relationship between relation between pressure and volume, and you need to keep temperature of the gas constant. So let's write its statement. Its statement is, let's say if there is a cylinder and this is the same cylinder in two different situations, right? In the first situation, the movable piston is over here, and in second situation we have moved the movable piston down, and then of course some gas particles are there inside it, Okay, so this is first at the start and this is at the end. So its volume is V1 and let's say its pressure is P1 and its volume is V2 and its pressure is P2. So temperature of both um like temperature of the gas in both the situations is kept constant. So this is constant, like you can't change the temperature. So obviously when the volume is more, then pressure is less because molecules are far apart from the walls, so they can't reach wall quickly and they can't hit the wall more frequently. But in situation 2, molecules are at the closest position to the walls, so they are hitting frequently with the walls, resulting in increase in pressure. So the statement is uh, pressure of gas is inversely proportional to volume, and there is a condition for every law keeping temperature constant. Like you have to keep temperature of the gas constant. So its equation is pressure inversely proportional to volume keeping temperature constant unchanged. Like you can't change the temperature. You can write over here temperature is unchanged. Okay, now equality into like proportionality into equality, and then this will be PV is constant. So this is first main equation, and applying this to the upper situation, P1 V1 equals P2 V2. It means product of pressure and volume of the gas will always remains the constant if you keep temperature constant. So that's the second statement as well. Product of pressure and volume of gas at constant temperature remains same. Like this is the alternate statement for Boyle's law. Okay, let's move on. Let's make some graph for the Boyle's law. Okay, as you know, pressure and volume are inversely proportional, right? So this shows that whenever you will increase the volume, the pressure will decrease because these are inversely proportional. So it means that volume is independent. You have to take it along x-axis, and pressure is independent. Pressure is dependent. You need to take it along y-axis. So the graph would be like this, right? So this would be the graph. The second graph, and this is a fixed graph for such type of relations. Okay, there is a second graph as well, and that graph is for 1 over V, like you take reciprocal of the volume against pressure. So then look, pressure is directly proportional to 1 over V. So you will say pressure is directly proportional to 1 over V, right? And in the upper it was pressure inversely proportional to volume. So now pressure is directly proportional to 1 over V, so it would be a straight line through origin. So if the graph is of 1 over V, right, if the graph is of 1 over V against P, it would be a straight line. But if the graph is only of volume against pressure, then it would be a inverse graph. You need to be careful with these because they can ask you in the MCQ just to identify it. Okay, um, right, so let's do an example for the Boyle's law. The example is that at um, pressure of 2.5 atm. Atm is the atmospheric pressure unit, so it is a unit of pressure, right? Atm is unit of atmospheric pressure. Like it can be Pascal, but It can be atmosphere as well. Okay, so at pressure of 2.5 atm of air in a cylinder at volume V naught, if volume is decreased to 1/6 of original volume, then find new value of gas pressure, new value of air pressure in cylinder. Okay, this is the question, and I can make a diagram for you as well. Let's say this is the cylinder and a movable piston is over there. This is the movable piston, right? And of course some air is over there in it. So this is the air. So right now its volume is V naught and its pressure is 2.5 atm. This is pressure and this is volume. Now what they are saying is that you're going to decrease the volume to 1/6. 1/6 mean obviously you have decreased like 6 times to that of original. Let's say for instance it's like this. So now the volume is 1/6 of original, 1/6 V naught, and you need to find the new pressure. So as we know that P1 V1 is P2 V2, so you just need to insert the values into it. So P1 is what? It is 2.5. V1 is what? It is V naught. P2 is what? You have to find. And V2 is what? 1/6 V naught. So now this V naught cancels away and shift 6 on the other side. So it will be P2 is 6 into 2.5. So that will be 15 atm. So this will be the new pressure. Okay, so let's move on. In case of any doubt, beta, you can ask because you're not talking at all, so it seems really odd. Okay, so let's move on to the second law, and second law is Charles law. Okay, beta. Charles was the, of course, name of the scientist. So Charles law is basically a relationship between volume and temperature, right? So it states that volume of gas is directly proportional to temperature, keeping its pressure constant. Like in gas laws, you need to keep one thing constant and then you study the relationship between rest of the two. Okay, so volume is directly proportional to temperature. So volume proportional to temperature, and then volume is constant into temperature, and then volume over temperature equal constant. So this is the main equation. Or you can also say V1 over T1 equal V2 over T2. So this is in two situation. And let me draw the cylinder for you. Let's say uh, This is a cylinder and it is fitted with a movable piston. This is movable piston. It can move up and down. And of course some gas is over there. So right now its volume is V1 and its temperature is T1 and its pressure is P. So now what we will do is we will supply some heat energy to it. So when we will supply some heat energy to it, what will happen is the gas molecules start moving vigorously. They start colliding with the walls more frequently, and they start exerting pressure all over, and in the similar way they exert a pressure on the piston as well, hence moving it upward. This is force exerted by gas molecule. So the new volume increases and new temperature increases as well, but the pressure remains the same. Pressure will remain the same. Okay, so why pressure remains the same? Because as you increase the temperature, but volume is also increase, right? So we know that when volume increases, pressure decreases, but we also know that when temperature increases, pressure also increases. So the pressure effect is neutralized, so pressure in both the situation will remain the same. Okay, let's move on to the third law, the last law, which is pressure temperature law. Okay, beta, pressure temperature law. So uh, the statement is quite simple, which is pressure of gas is directly proportional to its temperature, keeping its volume constant. This time we are keeping the volume constant. Okay, if we talk about its equation, pressure is directly proportional to temperature and volume will be unchanged. So it means pressure is constant into T, because whenever you change proportionality into equality, you need to assign a constant. It means pressure over temperature is constant. So it also means that P1 over T1 equal P2 over T2. So this will be the formula that you will use. Um, in the previous, we need to make the graph, although the graph is very simple, volume and temperature. So temperature is over there and volume is over there. So as both are directly proportional to each other, so you know when two things are directly proportional to each other, the graph is always a straight line through origin. So it's always straight line through origin, right? Okay, now in the similar way, we need to make the graph for this as well, pressure with temperature. So again, it's the same thing. It should be directly proportional, so straight line through origin, right? Because both are directly proportional to each other. And if I can draw a cylinder for you, in which I will describe the whole situation. So let's say we are having a fixed cylinder, like this is fixed and it is having some gas in it, like this is the gas, and then there is a pressure gauge as well. This is pressure gauge meter. Okay, so over here The temperature will be T1 and the pressure will be P1 and the volume is V. Okay, when you will change the temperature, of course, you will supply heat from the bottom. You will heat it up. So when you will heat it up, what will happen? The molecules would start moving vigorously. The molecules will move quickly and their speed will increases and their collision will increases as well. So when their collision will increases, their pressure will increase, temperature also increase, but the volume remains the same because it's a fixed volume cylinder. That's why you can say P1 over T1 is equal to P2 over T2. So let me tell you summary of it. Um First was Boyle's law. Second was Charles law, and third was pressure temperature law. Talking about their equation, this is PV is constant. This is V over T is constant, and this is P over T is constant. Or furthermore, you can also write them like P1 V1 equals P2 V2. This will be used in the numericals. V1 over T1 equal V2 over T2, and then P1 over T1 equal P2 over T2. So these equations will be used in the numericals, and it will be very simple numericals because three things would be given and you need to find uh, one thing, right? So that was the thing. Just hold on.